Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence that the quality of video as well as audio, is it perfect or not? If it is perfect, just write perfect over the live chat. Anyways, the agenda behind today's video is very clear over the thumbnail. We are going to discuss about the concept of the gain margin and phase margin. This is the topic I have seen many of the students used to have conceptual doubts. So what I have done, I am going to discuss briefly about the theoretical part of the gain margin and phase margin, and end of the day we are going to take the 10 number of numericals which have come into the GATE examination. End of the day you would be more than thorough with the concept of the gain margin as well as phase margin. Agreed? So I would request to each one of you, just put the heading as the gain margin and phase margin. This would be the agenda behind today's session. Anyways, before going into the detailed analysis of the gain margin and phase margin, it is better to write few of the important point. The first important point, why the gain margin and phase margin itself is being calculated, because many of us do not have the fair idea why the gain margin and phase margin is calculated for any given system. Keep in mind, so far we were talking about the relative stability, like we have the two number of systems. So just we were watching which of the system is stable and which of the system is unstable. Never we talked about the amount of a stability. That means if you have a stable system, you were not able to quantify how much that system is a stable system. Agreed what I am saying? So what is the gain margin and phase margin? The gain margin and phase margin talks about how much stable a system is. How much stable a system is. That means gain margin and phase margin talks about the relative stability of the system. Yes, that's the first and very important point within the gain margin and phase margin. So far we were just talking whether the system is a stable or unstable system, but now we would also quantify how stable a system is. Like you can have the two number of systems, among them one is a higher stable system and another is a lower stable system. Although both are stable system, how will you quantify which one is higher stable and which one is lower stable? You would just quantify by their values of gain margin and phase margin. Agreed what I am saying? Let's take, if you have got the two different systems, for the time being, let's take you had a system 1 whose phase margin, let's take, is 50 degree and gain margin, let's take, is 5. And similarly you had another system S of 2 whose phase margin, let's take, is 35 degree and gain margin is equals to 2. Anyways, both of them are stable system. Once we'll go into the detailed study of the gain margin and phase margin, we'll get to know if the phase margin is positive as well as gain margin is greater than 1, both would be a stable system. But once you will compare their phase margin as well as gain margin, you got to know here the margin is more in terms of phase as well as in terms of gain. So at least you can quantify the system 1 is more stable than the system 2. But how could you figure out? You could figure out with the help of values of phase margin and gain margin. That is what I am saying. In future, if you want to quantify a system, how stable a system is, you should also give its values of phase margin as well as gain margin. You can see very well the system 1 is more stable than the system 2. System 1 is more stable. System 1 is more stable than system 2. Somewhere you can write higher the value of PM and GM, higher the stability. I would repeat once again, higher the value of PM and GN, higher the stability. The first point must be clear to all of us. That's fine. Let me go ahead with the second important point. See, once you would be calculating the value of gain margin as well as phase margin, two more reference frequencies has to be calculated. That is nothing but the gain crossover frequency, phase crossover frequency. So let me do one thing. Let me list out all of the important parameters which we would be studying within the concept of gain margin and phase margin. So write down the important, I can go into the next page, the important terms. important terms which we would be studying under the concept of phase margin and gain margin. Phase margin and gain margin. Yes. The first and the important term which we would be coming across many of the times, and that is nothing but the phase crossover frequency. Write it down. Phase crossover frequency. Frequency. In short, I would be referring this as omega PC. Omega PC. Anyways, what is the usage of omega PC? Once we'll go into the concept of gain margin, we would take the reference of omega PC. Anyways, keep aside each and everything. Just focus over the phase crossover frequency. May I know how the phase crossover frequency is defined as definition? It is being defined by the frequency at which the phase offered by the OLTF is precisely minus 180 degree. So you can write, that's a very, very important one. Write down frequency at which phase offered by OLTF is precisely minus 180 degree. If mathematically you would like to write this, so it would be simply the phase offered by the OLTF in frequency domain can be written as Gj omega Hj omega precisely at omega is equals to of omega Pc, it is minus of 180 degree. Minus of 180 degree. Agreed? So whenever I refer the omega Pc, by default one thing should come in your mind. The omega Pc is the frequency at which the phase offered by the OLTF is precisely minus 180 degree. Let me put inside a bracket. So let me take an example. So with the help of that example, probably you would be able to understand this concept even better. Let's take an example. I am going to take an example. Find the phase crossover frequency. Phase crossover frequency of a OLTF. Let's take the OLTF is GSHS is equals to 1 divided by of S plus 1 to the power of 3. I need to find the phase crossover frequency for the given OLTF, which has been defined as a 1 divided by of S plus 1 to the power of 3. Anyways, go ahead with this solution. First step would be change the domain of operation from S domain to omega domain. So obviously GSHS would become Gj omega Hj omega Hj omega. S would get replaced with the j omega to the power of 3. My focus is just to get the angle offered by this complex function, which is nothing but 1 upon j omega plus 1 to the power of 3. It has been communicated earlier. If the transfer function comes towards the denominator side, definitely impact used to be the negative in nature. And how many times this pole have got repeated? 3 times the pole have got repeated. So the 3 would get multiplied with its effective angle. So anyways, if we'll talk about the angle offered by Gj omega, virtually angle offered by 1 divided by j omega plus of 1 to the power of 3. Keep in mind, because of j omega plus 1, which is there towards the denominator side, first focus over the j omega plus 1. How much angle it would offer? It's going to be tan inverse of imaginary part. Imaginary part is nothing but omega, and the real part is nothing but 1. Simply tan inverse omega. As this factor is coming towards denominator side, definitely the minus would get multiplied, and the 3 times this pole have got repeated. So this factor would be simply equals to of minus of 3. Agreed? And as we are looking for the value of omega Pc, what I had to do? I had to find the value of omega where angle offered by the OLTF precisely becomes minus 180 degree is nothing but the phase crossover frequency. So what I would do? I would just compare minus 3 tan inverse of omega with minus 180 degree, the frequency at which the angle offered by the OLTF attains minus 180 degree, that frequency would be phase crossover frequency. So may I know exactly how much value of omega or omega PC we are getting? See, this minus and minus goes off. This 3 would go towards right hand side, and the factor which is coming in my hand is simply gonna be tan inverse of omega, yes, is equals to of how much it is? 60, no? Again I would repeat, it's gonna be 180 divided by 3, that's a 60. The omega is gonna be 1060. 1060, and that is nothing but the phase crossover frequency, or the phase crossover frequency is precisely equals to of root 3. Could you understand? If this process is clear, just write clear over the live chat, so at least I'll get to know you have a fair idea how to get the value of omega PC. Whereas if we'll take a complex problem, definitely the in between there was a problem with video, and probably everything is fine, no? If it is fine, just write fine over the live chat, so at least I'll get to know there is no buffering from your side. May I know each and everything is fine or not? If it is fine, just write fine over the live chat. So at least we could know one thing, the value of omega PC is equals to of root 3. In the same sequence, now we are going to define the concept of gain crossover frequency. So let me take the next page, and here I would be discussing about the gain crossover frequency. And as the phase crossover frequency was written as omega PC, the gain crossover frequency would be written as omega GC. Yes, omega GC. Anyways, let me write the definition first. The frequency at which the gain offered by OLTF is unity in linear scale, and similarly if we convert into the dBs, what we had to do? We had to apply a log over the unity, means 1, the value would become 0. So we can write frequency at which gain offered by frequency at which the gain offered by OLTF is unity. What does that mean of it? 1 in linear scale, or becomes 0 in dBs. See why we have taken the two different definitions. See, the magnitude was calculated in linear scale when I was dealing with the polar or the Nyquist plot, and similarly when the same concept is dealt with the concept of Bode plot, there the magnitude used to be calculated in dBs. That is why I have taken the two different definitions. What does that mean by the frequency of omega GC? The frequency at which gain offered by the OLTF is unity, that's fine, and similarly the gain offered by the OLTF is 0 dBs. When this concept would be used? When I would be smashing the problem with the help of Bode magnitude plot, and similarly when this concept would be used? When I would be smashing the problem with the help of polar or the Nyquist plot. That is why the two different definition has been taken place. Anyways, mathematically how I can write this? So the gain offered by the OLTF in frequency domain precisely goes to 1, that operating frequency omega is called omega GC. You can write this as a first definition. And similarly, the magnitude offered by the OLTF precisely becomes 0 dB. There omega would be omega GC, that is also okay. GJ omega, HJ omega. Omega is equals to of omega GC. And as you have taken 20 log towards the left hand side, so the 20 log has to be taken towards right hand side, and here it simply becomes 0. Agree? So whenever we talk about the omega GC, basically you had to find the value of operating frequency at which the gain offered by the OLTF is unity in linear scale or 0 dB in logarithmic scale. Agreed? Till this point nobody should have any doubt as such. So let me take an example. And as I have said, I would be explaining the concept of gain margin and phase margin in the great detail. That is why I am going to take the example for the each and individual definitions. Let's take here 2 root 3. This is what my OLTF is. This is what my OLTF is. Find the value of, I wanted to know, find the value of omega GC. Yes. May I know what would be your approach? I need to get the magnitude offered by the given OLTF in frequency domain. So here it becomes the magnitude of the given OLTF in frequency domain, j omega within the bracket j omega plus 1. The frequency at which the gain offered by the given OLTF becomes 1 in linear scale, that operating frequency is nothing but the gain crossover frequency. Yes, till this point nobody should have any doubt as such. And whenever we deal with any complex function, if we require to have the magnitude, I can take its magnitude towards the numerator separately as well as denominator separately. Not only that, even the magnitude can be taken separately for the each of the individual factors. So put together, it's simply gonna be 2 of root 3 divided by of magnitude of j omega would be simply equals to of omega, and here it becomes omega square plus 1. At omega is equals to omega GC, the magnitude would be simply equals to 1. May I know what would be the value of omega GC? Either you can do one thing, you can shift the denominator towards right hand side, it will make a quadratic equation, and from there you can get the answer of omega GC. That would be your first step. Or otherwise, with the help of hit and trial method also, you can get the value of omega. See, if you are feeding omega GC is equals to of root 3. See, if you will feed omega GC is equals to root 3, this root 3 would come over here. It would become root over of root 3 square, that's just 3, plus of 1, that is 4. Root over 4 is nothing but 2. So this factor becomes 2 and this factor is already root 3. Both of them would be cancelling each other, and end of the day you got to know the value of omega GC is precisely equals to 1. Yes. So whenever we come across the calculation of omega PC, what I would do, I would calculate the angle offered by the OLTF and would compare with the minus 180 degree. The frequency at which the angle offered by the OLTF is precisely minus 180 degree, that is the operating frequency, is called phase crossover frequency. Yes. And now if we focus over the gain crossover frequency, so what I do, I first get the gain of the given OLTF and compare with the one in linear scale. The frequency at which it happens is called omega GC. Yes. So let me do one thing. Let me focus over the next two important terminologies, and they are nothing but phase margin and gain margin. See, what does it mean by the phase margin? The name itself is self-explanatory. It's a margin in phase. That means how much phase can be introduced within the system, still the system is a stable system. Could you understand what I am saying? See, what I am saying, it is the margin in phase. If a system is a stable system, I would like to know how much stable that system is. That would be accounted by the phase margin. If it has higher margin in phase, that means I can introduce more and more phase lag into the system. Still the system is a stable system. Agreed? So better to write the definition of the phase margin. Write down. Phase lag can be provided to the system to bring system into the verge of instability. You can write one more important thing, keeping gain constant. Keeping a gain constant. Agreed? What does it mean of it? I would repeat what I wanted to communicate. If your system is having a higher phase margin, that means you can introduce more and more phase lag to the system, still the system would remain a stable system. That means the higher the margin in phase, higher a stable system is. Higher a stable system is. That is why at very beginning I have taken two different systems. There where the phase margin was higher, I took that system as a stable system because there I can introduce more amount of phase lag, still the system would remain a stable system. Agreed? Anyways, mathematically how the phase margin is being calculated, the phase margin is calculated as 180 plus of angle offered by the OLTF at omega is equals to of omega GC. Many of us would used to have confusion, sir, why don't we take omega PC instead the omega GC as our focus is towards phase? No, the reference used to be omega is equals to of omega GC. Yes, till this point nobody should have any doubt as such. Why the reference has been taken for the omega GC? Once I would come into the next few number of problems, I would reveal each and everything why the concept of phase margin is just been defined at omega is equals to omega PC, because each and everything have got its own theory. Nobody should have any doubt as such. See what I am saying? Whatever the concept I have narrated so far, each and everything have got its own basis. So once I will be taking few number of problems, with the help of each and individual problems, I am going to unfold many number of concepts. So you need not to worry about it. Again I am saying the point where most of us used to have the confusion. In case of phase margin, I used to take the reference of gain crossover frequency. Why? Once I will go into the graphical analysis, the things would be much clear, much clear. Anyways, let me take an example. The problem which I have taken in the last page, I am just recalling that question again. See, let me take the same problem. That means 2 root 3 divided by of s into s plus 1. 2 root 3, this is what the problem is. Let's take, I am going to take an example. The example is 2 root 3 divided by of s into of s plus 1. Find the value of phase margin for the given OLTF. May I know what would be the steps of calculation? See, until and unless you are not aware with the omega GC, definitely you won't be able to get the value of phase margin. So first focus over the omega GC. What does it mean by the omega GC? The omega GC is the operating frequency at which the gain offered by the OLTF would be precisely 1 upon root 2. Precisely 1. And probably if you would be able to recall, the omega GC is already been calculated for this problem and the value was found to be root 3. If you want to cross check, you can cross check once again. If you'll keep root 3 and here it's gonna be root 3 to the power of 2, that's a 3 plus 1, that's a 4, root over of 4 would become 2. 2 and 2 is going out, and similarly root 3 and root 3 is going out. So obviously at omega is equals to omega GC is equals to root 3 radian per second, the magnitude offered by the OLTF is precisely 1. Agreed? Nobody should have any doubt as such. Now my focus is towards the phase margin. Again I am saying from where this formula have come, definitely I am going into the detailed analysis of that part also, but for the time being keep aside, because I had to learn each and everything step by step. Otherwise it won't be that easy to understand each and everything in once through. So may I know how the phase margin is being calculated? I need to add 180 degree in the angle offered by the system at omega is equals to of omega GC. May I know how much angle it would be offered? Because of the factor 1 upon s, definitely there would be an introduction of minus 90 degree irrespective of the omega. And similarly because of s plus 1, there would be an introduction of the factor tan inverse of omega in angle. Yes. And now this angle has to be calculated at omega is equals to of omega GC. At omega is equals to of omega GC, how much it is? It's root 3. Is root 3, and whatever the answer comes, that's gonna be your phase margin. Tell me how much phase margin we are getting for this problem. So you can see very well, 180 minus of 90, that would become simply 90, minus of tan inverse, the gain offered the at omega is equals to root 3. So here is gonna be minus of 10 inverse of root 3. So here comes 90, just a minute, minus of 10 inverse root 3 is nothing but 60. So here I got the margin in phase as 30 degree. Margin in phase as 30 degree. Agreed what I am saying? Obviously the best most answer which we are getting for this problem is going to be 30 degree. Now do one thing, let me go ahead with the concept of gain margin. Try to understand what does it mean by the gain margin. As we had the margin in phase, now we would be discussing about margin in gain. Like in case of phase margin, I was discussing how much margin you have in terms of lag such that the system remains stable, or if you keep pushing the system towards the lagging side, end of the day how much lag you can offer to the system that the system reaches to the verge of its instability. The same thing. Now rather changing the angle of the system, I am changing the gain of the system. And now here I would watch how much gain I can offer within the system such that the system reaches to the verge of the stability. Anyways, until and unless I would not go into the graphical understanding of the gain margin and phase margin, probably nobody is going to understand the basic concept behind the gain margin and phase margin. Many of us used to have doubts, sir, from where this formula have come out, and similarly the formula which would be written for the gain margin, from where that formula have come out. What is the basic concept of the gain margin and phase margin? Many of us would used to have a doubt. Anyways, let me write each and everything step by step. End of the day, with the help of problem, I am going to unfold the actual concept behind the gain margin and phase margin. Need not to worry about it. Yes, the gain margin, what does it mean of it? The same definition, there would be a bit difference. See, the phase lag can be provided here, the phase can be provided to the system to bring the system into the verge of instability. In case of phase margin, I was not allowed to change the gain. In similarly, in case of gain margin, I would not be allowed to change or introduce phase change over the system. Agreed what I am saying? So here the same definition would be used. Gain provided by the system, to bring system to the verge of instability. Within the bracket, without changing or without introducing phase into the system, without changing phase. I would request to each one of you, do not leave this session, because this session is ultra important session. The gain margin, the gain provided by the system to bring the system to the verge of instability without changing its phase. That means how much margin we have in terms of the gain which we can offer the OLTF such that the OLTF reaches to the verge of its stability or instability. Now may I know each and everything is perfect, because in between I got few number of comments that the video is buffering. May I know each and everything is perfect now? If it is perfect, just write perfect over the live chat. Verge of stability, verge, that means you are moving from the stability to instability or instability to stability. That means you have been kept yourself towards a marginally stable range. Yes, so you need not to have any confusion. Either I call it verge of stability or verge of instability. Verge means it is a borderline. Towards the left hand side the stability is there, and towards right hand side instability is there. So in few of the books you would be getting this definition as a verge of stability. In few of the books you would be getting this definition as a verge of instability. So nobody should have any doubt as such. Yes. May I know how the formula is being written? The formula is being written gain margin in linear scale, as the gain can be calculated in the linear scale as well as dBs. That is why even the formula for the gain margin has been bifurcated in the two part, first in the linear scale and the second in the dBs. Anyways, how it's been calculated? It's been calculated 1 divided by the magnitude of the given OLTF precisely at omega is equals to phase crossover frequency. Phase crossover frequency. Agreed? Similarly, if we calculate the GM gain margin in dBs or in logarithmic domain, so I would be taking log towards the right hand side, so log of 1 would become 0, and similarly it becomes 20 log mod of gj omega hj omega at omega is equals to omega pc. As this factor is towards downside, definitely the factor which would come out is going to be simply equals to minus 20 log base 10 of mod of gj omega hj omega at omega is equals to of omega pc. At omega is equals to of omega pc. Till this point nobody should have any doubt as such. Yes, so this is the two important formulas we should remember, but end of the day you will also know from where these two formulas have come out. And may I know, for a stable system, what must be the value of phase margin and what must be the value of gain margin? See, if phase margin is positive, that means you can provide the lag into the system. Still a system is a stable system until you are providing your phase lag till phase margin. That is why I am saying whether you have the margin in phase or not, that would be solely defined by the phase margin. If phase margin is positive, that means you are allowed to give a good amount of phase lag. Still the system is a stable system. What does that mean of it? Anyways, you may not be able to visualize. I wanted to communicate over here. Just you can write for the time being. For a stable system, phase margin has to be a positive value. For a stable system, phase margin has to be a positive value. Phase margin has to be a positive value. And similarly, for a stable system, gain margin has to be greater than 1. And if I take a log of 1, definitely it becomes 0, and hence for a stable system, the gain margin in dBs has to be greater than 0 dBs. Yes, has to be greater than 0 dBs. So do one thing. See what I am going to do, what I have planned for the today's class. I have given a just brief idea about the concept of omega PC, omega GC, GM, PM. Now straight away I would be jumping on to the problem which have come into previous years of GATE as well as EAC, and from there we would try to learn so many number of good concepts. So let me go into the first question. What the problem states: for a stable system, gain margin and phase margin both are positive. Gain margin and phase margin both are negative. Gain margin is positive and phase margin is negative. Gain margin is negative and phase margin is positive. May I know what would be the best most answer? For a stable system, definitely phase margin has to be positive value, and in case of gain margin for a stable system, it has to be greater than 1 if the gain margin is calculated in the linear scale, and similarly has to be greater than 0 when it is calculated in dBs. Agreed what I am saying? Till this point nobody should have any doubt as such. That means once you watch carefully each and individual options, at least you can guess one thing: the gain margin was calculated in dBs. And if the gain margin is calculated in dBs, for a stable system, gain margin has to be greater than 0 dB. Put together, it has to be positive. Agreed? Till this point nobody should have any doubt as such. Now here comes the next question. The problem have come in engineering services examination year of 2005 in paper of electronics. Let me read what the problem states. If gain of the loop system is doubled, the gain margin of the system is not affected, doubled, halved, 1/4 of the original value. May I know what would be the exact answer for the given problem? Tell me what would be the exact answer? Tell me. Tell me, what would be the best most answer? The answer have started coming, one answer have come as halved. See, try to understand what I wanted to communicate in this system. If gain of the loop system is doubled, what does that mean of it? Rest of the component or the rest of the parameter has not been touched, only the factor of gain has been touched with the open loop transfer function. So may I know what would be the effect over the gain margin? Anyways, how the gain margin is being calculated? The gain margin is equals to of 1 divided by of mod of k g j omega h j omega at omega is equals to of omega pc, omega pc. Yes. Now in second condition, what I have done, I need to calculate the new gain margin when only one change has been taken place. What it is? Initially gain was k, now it has been changed to the twice of k, twice of k. The rest of the factor remains as it is. That means as such there is no change into the OLTF. May I know, I would like to ask one thing from each one of you. If the value of k has changed from k to 2k, the value of omega pc would remain same or would it change? Again, I would ask one thing. If the value of k, the gain was changed from k to 2k, the value of omega pc would remain same or would it change? It will remain very same. Why? Because if omega pc, or sorry, k is a positive value, it is not going to introduce any amount of phase within the system. Either it is k, either it is 2k. And here it is gm2. So definitely I can take their ratios. You can see very well, this factor is gonna be very same. This factor and this factor is gonna be very same. So if you talk about the gm 1 divided by of gm2, it's simply gonna be, this 2 would come towards the numerator side, simply becomes 2 divided by of 1. So after increasing the gain from k to 2k, we got to know the value of gm as gm2, and which is simply equals to of gm1 divided by of 2. So you can see very well, the gain just got halved. The gain just got halved. Agreed? Anyways, many of us may not be able to understand what I wanted to communicate exactly. See, the k is a positive real component which would not lead any of the phase component, and if the k as well as 2k is not introducing any of the phase shift, keep in mind what's the omega pc is being defined. The omega pc is the phase offered by the system precisely equals to of minus 180 degree. Because of k and 2k, there is no introduction of the phase within the system. In that case, the omega pc would remain same in the first as well as second scenario. That is what the point where many of the students do mistakes. Like many of the students may not be able to even understand. They will just cut out the numerator and denominator and they will just writing the value as 1 upon 2. No, my dear friends, you should have also a clear-cut idea. There would not be any change in phase crossover frequency if the gain has been changed. Agreed? Till this point, nobody should have any doubt as such. Let me go ahead with the next question. The problem have come in engineering services examination, year of 2010, the paper of electronics. Anyways, it's called Nichols chart. Usually does not come in gate examination. How PM affected in this case? I would be discussing each and everything. Probably few more questions are supposed to come, and there I need to discuss about those things also. See what the problem states. For the Nichols chart plot shown in the system, tell me whether it's a stable system, whether it's an unstable system. If the phase margin and gain margin both are positive, definitely it would be a stable system, and if phase margin and gain margin is negative, definitely it would be an unstable system. Anyways, how would we going to know the value of phase margin and gain margin? I need to focus over the phase margin and gain margin. If you guys would be able to recall, the phase margin was calculated taking the reference of omega GC. Yes, the phase margin was calculated taking the reference of omega GC, and similarly the gain margin was calculated taking the reference of omega PC. If you would be able to recall what was the formula for the phase margin, I need to add 180 degree into the into the angle offered by the system gj omega hj omega at omega is equals to of omega gc. Omega is equals to of omega gc. Yes. May I know what does that mean by the omega gc? The omega gc is nothing but the frequency at which the gain offered by the OLTF is 1 unity in linear scale, 0 dB in logarithmic scale. And you can see very well the y-axis is dedicated to the magnitude or the gain offered by the OLTF in dBs, and similarly x-axis has been dedicated towards the angle offered by the OLTF. Yes. So may I know how will you get the angle offered by the OLTF at omega gc? See, first focus over the 0 dB line, 0 dB line. You can see very well, this is the point where the gain offered by the OLTF is 0 dB. Yes. And precisely at that operating frequency omega gc, you need to calculate the angle offered by the system. What you would do? You would take a vertical line. Exact angle which has been offered by the system is nothing but minus a 150 degree. And once you'll add them together, the result is gonna be plus 30 degree. So easily with the help of Nichols chart, you got to know the value of phase margin, which is equals to of 180 minus of 150 is equals to of 30 degree. Is equals to of 30 degree. Agreed? Nobody should have any doubt as such. Now if we talk about the gain margin, what we had to do? In case of gain margin in dBs, we need to just multiply minus sign with the gain offered by the OLTF at omega is equals to of omega PC. May I know what does that mean by the omega PC? The omega PC is a frequency at which the angle offered by the system is precisely minus 180 degree. May I know which is the minus 180 degree line? This is the minus 180 degree line. Yes. And you can see very well at minus 180 degree, you can see here the curve is intersecting. And at minus 180 degree, if you'll calculate the gain offered by the OLTF, you got to know the value is simply minus 10. So this factor is minus 10, this factor is minus 10, and getting multiplied with a minus, put together, it's just gonna be plus 10 dB. Plus 10 dB. Agreed? Plus 10 dB. So the gain margin is gonna be plus 10 dB. And similarly phase margin is gonna be plus 30 degree, plus 30 degree. Put together, it is gonna be a stable system. A stable system. Probably one doubt one person have. See what I am saying? Whenever you calculate the gain margin, you have to take the reference of phase crossover frequency. What does it mean by the phase crossover frequency? It's nothing but the minus 180 degree line. At minus 180 degree line, how much gain was offered by the OLTF is nothing but the minus 10, which is the worth of 20 log Gj omega Hj omega at omega is equals to omega Pc. You just had to multiply with the minus sign. So the minus got multiplied with the minus 10 became plus 10 dB. And similarly, once we talk about the phase margin, what does it mean by the phase margin? The phase margin is equals to of 180 degree plus of phase offered by the system at omega is equals to omega gc. What does that mean by the omega gc? The gain offered by the system is unity or 0 dB in logarithmic scale. You can see very well it is a logarithmic scale, so definitely I need to take the reference of 0 dB. At 0 dB you can see very well the angle offered by the system was minus 150, so definitely this minus 150 has to be fed in. The 180 minus of 150 precisely becomes 30 degree. Precisely becomes 30 degree. Agreed? Precisely becomes 30 degree. Precisely becomes 30 degree. So the best most answer is gonna be, obviously it is gonna be a stable system. May I know each and everything is perfect or the video is getting buffered? So I want the input from each one of you. I want the input from each one of you. If it is clear, just write clear so that we can move ahead. We can move ahead. Agreed? Now let me go ahead with the next question. Let me go ahead with the next question. A very simple design problem, although this sort of problems are not expected to come in the gate examination. It's a very, very basic problem. And probably within 30 to 40 seconds, you would be able to address this problem well. Tell me, what would be the best most answer for this given problem? First, focus over the wording of the problem. See, Gj omega 2 Hj omega 2 is not equals to of 0. Omega 2 is phase crossover frequency, then gain is. Just a minute, just a minute, just a minute. One mistake is there. Yes. You can just put it equals to. You can just put it equals to. Tell me what would be the best most answer. What would be the best most answer? See what the problem states. Mod of Gj omega 2 Hj omega 2 is equals to of 0.125, where omega 2 is the phase crossover frequency, then the gain margin is equals to. And even once you'll see their options, the options were given in dBs. Options were given in dBs. That means you need to calculate the gain margin in dBs. You need to calculate the gain margin in dBs. May I know, while calculation of the gain margin, I used to take the reference of which frequency? I used to take the reference of omega Pc. And at omega Pc, I need to get the gain offered by the OLTF. I used to take its reciprocal and then I apply 20 log of 10. 20 log of 10. So here the gain margin is simply gonna be, which we have seen, the gain margin is simply gonna be 20 log of 1 divided by of mod of Gj omega Hj omega at omega is equals to of omega Pc, and you can see very well which was got to be minus 20 log base of 10 mod of Gj omega Hj omega, where the omega used to be omega Pc, and here it has been clearly given instead the omega Pc. Now the phase crossover frequency is being referred by the omega 2. And this magnitude is also given. May I know how much it is? The mod of Gj omega 2 Hj omega 2 is nothing but 0.125. So here goes minus 20 log base 10 of 0.125. Tell me how much the best answer we are getting. So each one of us has to calculate the value. Let me get the calculator. So here it's gonna be minus 20. Keep in mind it's a base of 10. No, nobody should use log natural. Here it becomes 0.125. So the answer which we are getting is simply option B, which is equals to of 18.06 dB. 18.06 dB. See, whenever the problem do come in the gate examination, there first you had to get the value of omega Pc, and with the help of omega Pc you had to get the gain offered by the system, and after applying this value or after applying this formula you would be getting the gain margin. But that is why I have designed the easiest problem where it was clearly given the gain offered by the system at crossover frequency was 0.125, then I need to get the gain margin. The gain margin is precisely going to be 18.06 dB. 18.06 dB. Is that part clear? Nobody should have any doubt as such. Now, let me do one thing. Let me go into the next question. It is a very well planned problem. Tell me what would be the best most answer. This problem have come in GATE Electronics year of 2015. The problem was framed by IIT Kanpur. Tell me what would be the best most answer. What would be the best most answer for this? Tell me what would be the best most answer for this. The phase margin in degrees of the system Gs is equals to of 10 divided by of S into S plus 10 is. S into S plus 10 is. Tell me what would be the best most answer for this given problem. May I know the video is running perfectly, no? Because I have doubt whether it's buffering in between or everything is perfect. If it is perfect, just write perfect over the live chat, so at least I'll get to know that each and everything is working perfect. Tell me, what would be the phase margin? May I know what would be your steps of calculation? See, there is no other way. First, you had to get the gain crossover frequency, and taking the reference of omega Gc, I would be calculating the phase margin. At very beginning, what I had to calculate? I had to calculate the gain crossover frequency. Omega Gc, I need to calculate. May I know how will we calculate the omega Gc? I would take the magnitude of just Gj omega Hj omega. May I know what would be the magnitude of it? It's going to be 10 divided by of omega, and here goes root over of imaginary square, which is omega square, plus of real square, that's 100. At omega is equals to of omega Gc, the magnitude offered by the given OLTF precisely becomes 1. Precisely becomes 1. Agreed? Precisely becomes 1. So may I know what would be the value of omega GC? This factor has to get transferred towards right hand side. I will take square both other side, and from there I would try to conclude something. So here it becomes 10 is equals to of omega root over of omega square plus of 100. To solve this problem, there is no other go. I had to take square both other side. If I take square both other side, it becomes 100 of omega square, which gets multiplied with the omega square plus of 100. Yes. Till this point, nobody should have any doubt as such. What I would be doing, omega square would get multiplied with the omega square and similarly with the 100. So the component which would be left out is simply gonna be omega to the power of 4, 100 into of omega square minus of 100 is equals to of 0. Is equals to of 0. Obviously, it's the algebraic equation with a degree of 4. What we can do to simplify this problem, I can keep omega square is equals to of x. Omega square is equals to of x. So here it becomes x square plus of 100 times of x square minus of 100 is equals to of 0. Is equals to of 0. So let me solve this quadratic equation and get the value of x. Straight away I am using the calculator, otherwise the calculator is not would be given in your examination. So here it's gonna be 100 and there it's gonna be minus 100. So the two value I have got it for the x. The x first value is 0.99. The second value is nothing but minus of 100 point something. Keep in mind, this cannot be the actual worth. Why? Because the x is equals to of root over of omega. Yes, the sorry. Yeah. So here the omega is nothing but the root over of x. If I'll take the root over of minus 100, definitely it would become a complex component and the omega cannot be a complex component. So obviously minus 100 has been ruled out. The component which would be used further is nothing but the 0.99. So from here we got to know the value of omega, which is precisely equals to of omega of GC is equals to of root over of 0.99. 0.99. Agreed what I am saying? So here it becomes, let me go out. Tell me how much we are getting. How much we are getting. So here it becomes root over of 0.99. 0.99. And that is nothing but again 0.994 something. 994 something. And as we are interested in finding the phase margin, how the phase margin is being defined? The phase margin is equals to of 180 degree plus of angle offered by the system at omega is equals to of omega GC, and here the omega GC is nothing but 0.994. 0.994. Agreed? So here comes 180 once again, and once you'll watch the factor involved with the given OLTF, because of S there would be an introduction of minus 90, because of S plus 10 there would be an introduction of the angle of 10 inverse of omega divided by of 10. The omega is nothing but 0.994 divided by of 10. Get the precise answer for this. Get the precise answer for that. So here it becomes 90, and here it is 90 minus of 10 inverse of 0.994 divided by of 10. Here comes 84.32 something. 84.32. This is the correct answer. This is the correct answer. So that means how much phase lag we can introduce within the system. Still the system is a stable system. Obviously we can introduce the maximum phase lag of 84.32 degree. 84.32 degree. Agreed? Agreed? Anyways, what is the meaning of the phase margin? First time we are going to understand. What is the meaning of phase margin. Each one of us would watch the next 4 to 5 minutes, which is very, very important. Let me do one thing. Let me rub this out. Yes, this went. Just a minute. Now try to understand in this way. If I draw the polar plot for the given OLTF, May I know what would be the starting angle? The starting angle is going to be minus 90 degree. May I know what would be its final angle? The final angle would be minus 180 degree, which we have seen in the last class. So here the starting angle would be minus 90, and similarly the ending angle would be minus 180 degree. And similarly at omega is equals to 0, the magnitude would be infinity because of loose pole, and similarly when the omega tends to infinity, definitely value will become 0. So here becomes your omega is equals to 0, and here becomes your omega is equals to infinity. Now we'll try to understand how the concept of stability is getting connected with the gain margin and phase margin. I have been talking about the stability in the last class. I was communicating whenever you are cautious or you are intended to calculate the stability of the system, you had to complete your given structure, which is nothing but the polar plot into the Nyquist plot. How would be the Nyquist plot? It is nothing but infinity minus, it is nothing but 0 minus, and this is nothing but 0 plus. Yes, agreed till this point? Nobody should have any doubt as such. I would ask from each one of you, nobody should have any doubt as such. Anyways, in this problem, they were asking the value of phase margin. I would ask from each one of you, if I would tilt towards clockwise direction, after certain tilting, would it enclose minus 1 plus j0? Yes or no? Just tell me yes or no. Yes. After how much tilting? After the tilting of 84.32. If you'll tilt here, once the tilt becomes 84.32, this portion would go from here, this portion would be here, and now the complete Nyquist plot would be sort of this. And if you take the phase leg more than 84.32, what would happen? Now the minus 1 plus j0 would get encircled, and once the minus 1 plus j0 gets encircled, keep in mind the system have become an unstable system. Agreed? Agreed? Here exactly I cannot say what's the problem I am facing. Probably there is something related to the software which I have been using, but still probably what I feel, now the quality of video and audio, would it be perfect? If it is perfect, just write perfect over the live chat. Yes. Now I would like to ask one thing. The phase margin was 84.32. If I would like to ask, or if I would like to calculate the gain margin of this given OLTF, may I know what would be the gain margin for this given OLTF? Tell me exactly. What would be the gain margin for this given OLTF? Tell me. I know many of the times the student would be able to tell me the value of PM, but most of the time they would not be able to tell the value of gain margin. Tell me, what would be the value of gain margin? Yes. One more important questions have been asked. Sir, after enclosing the minus 1 point, if cancels out the open loop pole? No, my dear friends, that's not possible. Keep in mind the concept of phase margin and gain margin is only and only defined for the MPS system, where neither the open loop pole nor the open loop zeros can be towards right hand side. If you want, you can write somewhere. The concept of gain margin and phase margin is only and only defined if the used OLTF is a complete MPS system. Agreed? It is a complete MPS system. Tell me, what would be the gain margin? I want the input from each one of you. What would be the gain margin for this particular open loop transfer function? I want the input from each one of you. Tell me, what would be the gain margin? Tell me, what would be the gain margin? Infinite. The first answer have come as infinite. That is what I am saying. What the people do, they first go ahead with the omega PC. and some of us would calculate the omega PC as infinity, and some of us would calculate the omega PC is equals to 0. You need not to go into the mathematical calculation, you just focus over its polar plot. You can see very well it reaches to minus 180 degree at omega is equals to infinity, even it does not cross to the minus 180 degree line. This part is clear? This part is clear? So once you talk about stability, definitely you have to draw its Nyquist plot. So here it goes the first segment, the infinity plus and infinity minus would be at same place, that would be its second segment, and similarly minus infinity to 0 minus, that would be the semantic to the older polar plot, that would be its third segment, and 0 minus and 0 plus would be encircled with the help of a clockwise direction, and now that has been the fourth segment. If you will just increase its gain, just try to understand in this way. If you will just increase its gain, what would happen? This structure would become more and more larger. Yes, larger. But none of the time it would be enclosing minus 1 plus J0. What does that mean of it? If you are keep offering the additional gain, none of the time minus 1 plus J0 would get encircled. That means for all possible high value of gain, system remains a stable system. System remains a stable system. Agreed till this point? So may I know what would be the gain margin of this system? Gain margin of this system is nothing but infinity. Gain margin of this system is nothing but infinity. Agreed? So any of us would have this sort of doubt. I have seen many of us used to have this sort of doubt. Do one thing, first draw its polar plot, then draw its Nyquist plot, and then do the stability over the Nyquist plane. Over the Nyquist plane, that's it. That's it. Agreed? Till this point, nobody should have any doubt as such. Now let me take the next question. And the next question would be the design problem. Let me take the problem is 1 upon s plus 2. 1 upon s plus 2. Tell me what would be the value of gain margin as well as phase margin for this. 1 upon s plus 2. What would be the gain margin as well as the phase margin for this OLTF? Tell me. So I would request, rather straight away jumping into the omega GC and omega PC, first draw its polar plot. How would be the polar plot? The starting angle would be 0 and the ending angle would be minus 90. And may I know at omega is equals to 0, what would be the magnitude? At omega is equals to 0, the magnitude is gonna be half. Magnitude is gonna be half, and the magnitude would be keep decreasing. At omega is equals to infinity, the magnitude would become 0, and the angle offered by the system would be precisely minus 90 degree. Minus 90 degree. Agreed? May I know what would be the gain margin and phase margin of the system? What would be the gain margin as well as the phase margin of the system? I know many of us would find this problem very difficult. See, why we find this problem very difficult? Because we have mucked up the two number of formulas. For the gain margin, this formula has to be used. For the phase margin, this formula has to be used. System is stable. It cannot go into the verge of 1. So obviously, that is what I wanted to say. Ajay, Mr. Ajay, that is why I wanted to communicate. So may I know what would be the value of gain margin and phase margin? See, stability has to be checked out with the help of Nyquist plot. So obviously I would close this out. I would close this out. Agreed? Here it is omega is equals to of 0 plus. For the better understanding, you can write infinity plus, infinity minus, and here it's 0 minus, 0 minus. Tell me what would be the gain margin as well as phase margin. Nobody should use the formula which I have communicated earlier, because neither you would be able to get the value of omega GC over here. Why you would not be able to get the omega GC over here? My dear friend, the maximum magnitude itself is half. Why the maximum magnitude is half? When the omega is least, the magnitude offered by the OLTF would be most, and that is nothing but the half. And as the value of omega is increasing, the magnitude is decreasing. That means none of the amount of the operating frequency omega, the magnitude offered by the OLTF would become 1. The maximum gain itself is half, and it is keep decreasing towards 0. How it will cross the magnitude of 1 line? Agreed? Agreed? And similarly, if we talk about the phase crossover frequency, no, that is also not possible. Why? Because the initial angle itself is 0 and the final angle is minus 90. How it would cross, or how it would attain an angle of minus 180 degree? Minus 180 degree. Tell me what would be the best most answer for the gain margin and phase margin. See, I have clearly communicated when I would be discussing about the gain margin, it's a margin in gain. how much margin I can pump into the system to reach to the verge of the instability or the stability or the encirclement of the minus 1 plus J0. See, if I would be giving more and more gain, see what would happen? This Nyquist plot would increase its shape. Yes. Agreed? But none of the time it is going to encircle minus 1 plus J0 until and unless a little bit tilt has not been provided. And it has been clearly told, whenever we talk about the gain margin, I cannot touch the face. In case of gain margin, I cannot touch the face and I just calculate how much gain I can pump it to the system such that the system reaches to the verge of the stability. Agreed what I am saying? May I know what would be the gain margin? What would be the gain margin? So the gain margin is simply going to be infinity. Yes, nobody should say, sir, if I'll multiply with the negative real value, in that case it would just get flipped and now it would enclose minus 1 plus J0. My dear friends, if you are multiplying with the negative real value because of minus, you are introducing minus 180 degree phase shift, which is not at all allowed. If you want, you can see over here. You can see over here. When we talk about the phase margin, I cannot touch the gain, and when we talk about the gain margin, I cannot change the phase. I cannot introduce the phase. Tell me, what would be the value of gain margin and phase margin? May I know each and everything is perfect? What would be the value of gain margin and phase margin? So obviously you are keep giving gain, it would be keep on expanding. It can't go towards left hand side. Why? Because here the magnitude is 0. If 0 is getting multiplied with a very, very high value, still it remains 0, no? So minus 1 plus J0 is not in danger. Agreed? Now, if we talk about the phase margin, now I cannot give the additional gain. So whatever the curve you had earlier, you can just give more and more and phase. Now, maximum magnitude itself is half. If you will start tilting it, so how the tilt would be? The tilt could be like this. May I know, would it enclose minus 1 plus G0 anyhow? No. It is not going to enclose minus 1 plus J0 anyhow, and hence how much phase lag you can give? You can give 180 degree, 200 degree, 300 degree, 360, 400. Still it is just rotating clockwise direction, but still it is not enclosing minus 1 plus J0. Put together, the phase margin is infinity. The gain margin is also infinity and phase margin is also infinity. If this part is clear, just write clear somewhere. So at least I will have one thing in your mind, that yes, I could communicate one of the good concept where I have seen many of us used to have very good amount of doubt. So could you understand what I am saying? With the help of only gain, you cannot enclose minus 1 plus J0. The gain margin is infinity. And with the help of only and only phase lag means shifting towards the clockwise direction. First was this axis, the second was this axis, the third was this axis. Probably I have given an phase lag of minus 135 degree. Here I have given the phase lag of maybe minus 225 degree. But nowhere it is enclosing minus 1 plus J0. Yes, till this point nobody should have any doubt as such. And I know still there are many number of points are there where most of us used to have doubt. So probably I may not be able to take those all points within this crash course, but I will try my level best to at least enlighten all of the points where we used to have common doubts. Agreed? No. Let me go ahead. Yes. Let me go ahead with the next. If you have a problem, 1 upon S into S plus 1. Please comment over the gain margin and phase margin. Which one would be finite and which one would be infinite? You need not to calculate the exact value I am saying. See, what I wanted to say, you should have a clear-cut idea, at least by visualizing the Nyquist curve, you must have a clear-cut idea The gain margin, would it be a finite, would it be an infinite? The phase margin, would it be a finite or would it be an infinite? Tell me, what about the gain margin and phase margin? Gain margin and phase margin. So I would request to each one of you, focus over the polar plot first. The initial angle would be minus 90 and the final angle would be minus 180 degree. Yes. Let me complete this polar plot and make it a Nyquist plot. Nyquist plot. May I know what about the magnitude over here? The magnitude is infinity. So in future, if you would tilt a bit, definitely after certain tilt, what I am saying, after certain tilt, it is going to enclose the minus 1 plus of J0 point. That means the phase margin is gonna be finite. That depends on the problem only. Yes, but if we talk about the gain margin, if you are keep increasing the gain, what is happening is still at omega is equals to infinity. The gain offered by the OLTF is infinity. So none of the amount of the value of omega, it would encircle minus 1 plus J0. It would be infinite. Yes. Agreed? Nobody should have any doubt as such. Till this point at least, nobody should have any doubt as such. Agreed? Now let me design another problem. See what we can do. Anyways, let me take few more number of problems which have come into gate examination. What has been asked in this problem? The gain margin of the system having the loop transfer is equals to of. Tell me what would be the best most answer. Without touching the pen, copy and paper, you must be able to get the exact answer for this given problem. Tell me what's gonna be the gain margin of this given problem. Gain margin. What is the gain margin of this given problem? I want the input from each one of you. The basic is already been taught and many of us would be able to give the proper answer for this given problem. Tell me what would be the best most answer. The answer is gonna be D, and still I know many of us have various number of fundamentals, various number of formulas. I have seen in many of the copies what the teacher used to say, if omega goes to infinity, gain margin is this, if omega tends to 0, the phase no, my dear friends, just focus over the basics of the Nyquist plot. End of the day, the problem is done. Agreed? And now let me discuss about its phase margin. Although it has not been asked in this problem, whether the phase margin, would it be infinity or would it be a finite value? Phase margin, would it be infinity or would it be a finite value? I want the input from each one of you. Phase margin, would it be infinity or finite? Obviously, phase margin has to be a finite value. Why? Because once you will watch its Nyquist plot, the magnitude is coming from infinity. So in future, if you will rotate this towards the clockwise direction, how exactly this curve would be? Let me draw somewhere. The curve would be sort of you have been taking the reference of this, now you can take the reference of this. See, the curve would be sort of this. See, it is enclosing, no? If you'll tilt a bit, definitely minus 1 plus J0 is getting enclosed. So the best most answer would be finite. But anyways, this problem may also be asked in terms of find the phase margin for the given problem, and this would be your homework. What is the phase margin for this given problem? Definitely it would be a finite value. Let me go into the next question. See, again and again same sort of problem are repeating. May I know what would be the gain margin of this system? Definitely the gain margin is gonna be infinity. But as far as this problem is concerned, they have been concerned about its phase margin. May I know what would be the phase margin for this exactly problem? Anyways, the phase margin would be a finite value. Now, until and unless you do not go, I would repeat once again, until and unless you do not go into the mathematical calculation, you would not be able to get the exact value of the phase margin. Yes. So what I would be doing? First, I would be calculating omega GC. gain crossover frequency. I have taken the reference of this formula, this problem at very beginning, where the value of omega was got to be, or omega GC was got to be root 3. End of the day, I need to take the phase margin. What would be the value of phase margin? That is 180 degree plus of the phase offered by the system at omega is equals to omega GC, which is nothing but 1 upon S would lead minus of 90 degree. Similarly, S plus 1 would lead 10 inverse of omega, where the omega is nothing but root 3. So 180 gets subtracted with the 90 would become 90. 10 inverse of root 3 is nothing but 60. So end of the day, the answer which we have in the hand is nothing but the 30 degree. Yes. Anyways, probably the same problem is already been used as an example when I started today's class. Agreed? Here comes the next problem. Anyways, this problem I would be taking after this problem. Tell me about the gain margin and phase margin. Which one is finite, which one is infinite? Although once you'll go inside the problem, they are just focusing over the gain margin in terms of dBs. But anyways, for the time being, keep aside each and everything. Just focus over this OLTF and tell me about its gain margin as well as phase margin. Tell me. Gain margin as well as its phase margin. It is an interesting problem. How it is an interesting problem? Try to understand in this way. See, the initial angle is gonna be minus 90. Agreed? The initial angle is gonna be minus 90. May I know what is the final angle? The final angle is gonna be minus 270 degree. Yes, here comes 0 plus, here goes infinity plus. Yes. So let me do one thing. Let me draw the complete Nyquist plot. So here would come infinity minus. Yes. Even you can mark the direction. Now I would like to ask one thing. The gain margin and phase margin, would it be finite or would it be infinite? Or the gain margin and phase margin partially would be finite and infinite. You can see very well, my dear friends. If minus 1 plus J0 is kept, let's take outside from this circular path. Even in future, if you'll provide phase lag, is still minus 1 plus J0 would get encircled. Even you will give the gain to the system, the complete structure would start bulging. If the complete structure would start bulging, may I know how the structure may look like? The structure may look like this also. And you can see very well the minus 1 plus J0 got encircled. It is a special category of the problem where the phase margin is also going to be a finite value, gain margin is also going to be a finite value. Agreed? Nobody should have any doubt as such. Nobody should have any doubt as such. Now, one of the very interesting point which I wanted to discuss. Let me do one more thing. Yes. Keep aside each and everything. Do one thing. Let's take a circle. With the radius of 1. Yes. With the radius of 1. May I know which point it is? It's a point where the magnitude offered by the OLTF is precisely 1. So this operating frequency would be omega GC. Nobody should have any doubt as such. Agreed? And as the value of omega is increasing, now exactly at this point, the angle offered by the OLTF is crossing through the minus 180 degree. So this is the operating frequency omega PC. Agreed? I would repeat once again because this is the point where many of us used to have difficulties. This is the frequency at which the gain offered by the OLTF. Keep in mind, once we talk about the Nyquist or the polar plot, the gain used to be in. linear scale, which is nothing but the unity. You can see very well the gain over the Nyquist plot or the gain over the polar plot is nothing but a constant circle line, and it is crossing the constant circle line with the magnitude of 1 at this point. So here the operating frequency would be omega GC. Omega 0, as it has been increasing, the magnitude is decreasing, and at omega is equals to omega GC, it is crossing my unity circle, and similarly here comes my omega PC. Here comes my omega PC. Now tell me, from where the two formulas have come? The two formulas we have seen, no? In case of phase margin as well as in case of gain margin. May I know how the formula of phase margin was taken as a 180 degree by the angle of the GHSS at omega is equals to of omega GC. Omega GC. Try to understand why it has come. Try to understand why it has come. You can see very well, you would calculate the angle offered by the system at omega is equals to omega GC. For that, what you would do? You would just extend the line from here, and that is nothing but the angle offered by the system at omega is equals to omega GC. For the time being, I can write this as phi. This as phi. And this data has been fed over here, and you got to know the value of phase margin. You got to know about the phase margin. And similarly, if minus 1 plus J0 is kept outside, minus 1 plus J0 is kept outside, and let's take at omega is equals to omega PC, the magnitude is, let's take A. Agreed? So may I know how much more gain I can provide to A such that the system would reach to the verge of the stability? So definitely the gain which I can provide, it's gonna be, let's take that gain is K. K into A is equals to of 1, and here the gain which I get is gonna be 1 upon A, and that is nothing but gain margin. That is nothing but gain margin. That means if it is being kept at 0.5, I can give the maximum gain of 2 such that it reaches to the verge of instability. That is why, my dear friends, whenever we discuss about the gain margin, I used to take the reference of omega PC. I used to calculate the magnitude of the OLTF at omega PC, and I reverse the magnitude at omega is equals to omega PC, and that is nothing but how much gain I can offer to the system. Yes. And similarly, if we talk about how much lag I can introduce into the system, I focus over the omega GC. First, I get how much phase was offered by the system at omega is equals to of omega GC, and thereafter I put that data over here. Anyways, what's gonna be the best most answer? Many of us would have got the answer. So may I know what is the best most answer? Anyways, focus this problem. I am focusing over the gain margin. First, get the phase crossover frequency. How the phase crossover frequency would be calculated? The phase offered by the Gj omega, Hj omega because of 100, no phase shift because it's a positive real quantity. Because of 1 upon s, there would be a phase shift of minus 90, and similarly because of 1 upon s plus 1, s plus 10 to the power of 2, there would be a phase shift of 2, 10 inverse of omega divided by of 10, and the frequency at which the angle offered by the system is precisely minus 180 degree, that frequency would be omega PC. Yes, omega PC. You had to calculate the value of omega PC. If any of us have calculated the value of omega PC, you can put it over the live chat. So at least I need not to calculate from here onwards. But the calculation is quite easy. Nothing great in it. So what happens? The minus goes out. This 180 gets subtracted with the 90 would become 90 divided by f2, that would become 45. 10 inverse becomes a 10 of 45, that would become 1. So the omega PC is simply gonna be 10 radian per second. 10 radian per second. Till this point, nobody should have any doubt as such. And if we talk about the magnitude in dBs, so what we are going to do? We are just going to calculate the magnitude of this OLTF at omega is equals to of 10, and we would multiply with the minus sign. So here the gain margin in dBs is gonna be minus 20 log base 10 of the magnitude of this. The magnitude of 100 is simply 100 divided by of s is 10. The magnitude of s is nothing but omega, so definitely it would be 10 as it is. Here goes omega square. Omega square is nothing but becomes 100 plus of 10 to the power of 2. And whenever we calculate this results, definitely tell me how much the answer is coming. probably it is coming 26 dB. You can check by yourself. Probably it is coming 26 dBs. 26 dBs. Yes. Till this point, nobody should have any doubt as such. And I would like to ask one more thing. If you guys are having any specific kind of doubt over the gain margin and phase margin, you can ask at least over the live chat, because probably I would not be able to cover the complete concept of the gain margin and phase margin probably in today's topic. So I would be just taking 1 or 2 more problem, and the remaining problem I would be taking in tomorrow's class. Tomorrow's class. Tell me. The next question, the open loop transfer function of a feedback control system GSHS is equals to of 1 divided by of s plus 1 to the power of 3. The gain margin of this system is, anyways, keep aside the gain margin, focus over the phase margin. Tell me, what would be the phase margin for this given problem? What would be the phase margin for this given problem? Tell me. Anyways, focus over the polar plot and then the extension of polar plot, Nyquist plot. The initial angle is going to be 0 degree. The final angle is going to be minus 270 degree. The maximum magnitude at omega is equals to 0 is 1, and similarly the minimum magnitude is going to be 0 at omega is equals to infinity. So what happens? It would start from here. And the magnitude would be keep decreasing, and it would just sink like this. Here goes 0 plus. Here goes infinity plus, and here would come infinity minus, and this structure would get completed. Yes, like this. Yes. Devraj, if the time permits, probably that also would be communicated, but probably I don't feel today I would have that much amount of time. Why the 180 is getting added? Definitely it has got the basis for the 180 degree also. See, each and everything have got its own basis. As I have communicating, at least in crash course we cannot go into the great detail, but as I was committed, at least in phase margin and gain margin, we are going to discuss the each and individual parts of the gain margin and phase margin. That is why the things has been taken in the great detail. And probably if the time is not permitting today, I would be taking the same concept tomorrow, why the 180 degree is getting added with the angle offered by the system at omega is equals to omega GC for finding the value of phase margin. Tell me, what would be the phase margin? The phase margin is going to be infinity. Why? If you will keep rotate it, the maximum gain itself is 1. If you would be keep rotating it, no, end of the day what would happen? After a rotation of 180 degree, the complete curve would become sort of this. Yes, the complete curve would become sort of this. And there also it is not intersecting minus 1 plus j0, it is just touching minus 1 plus j0. So in that case you can say the phase margin is approximately infinity. See, rather 1 upon s plus 1 to the power of 3, if it would have been 1 divided by s plus 2 to the power of 3, so the magnitude at omega is equals to 0 would have been 1 upon 8, and in that case if even I would rotate or if I would just give a leg, still minus 1 plus j0 would never be encircled, definitely would have been infinity. Tell me, what's going to be the gain margin? So first focus over the omega PC, the frequency at which the angle offered by the system is precisely minus 180 degree. May I know what is the angle offered by the given OLTF? 1 divided by of s plus 1 to the power of 3. It simply equals to of minus 3 tan inverse of omega. I have to compare with 180 degree. Minus goes off 3, it goes to be 60, and we know the the omega is equals to 10 of 60, which is equals to root 3. Yes, I need to get the gain margin. How will you get the gain margin? The gain margin is simply going to be 1 divided by of 1 of, so here it becomes 1 of a mod of s plus 1 to the power of 2 to the power of 3 probably at omega is equals to of root 3. Yes, Nowhere it has been given that I need to calculate the gain in dBs. So obviously keep aside each and everything. Get the value of what gain margin in linear scale. So the best most answer which we would be getting at omega is equals to root 3 is nothing but the 8. Nothing but the 8. Yes, so the best most answer which we are getting is nothing but 8. Is still around 2 or 3 more conceptual questions I am going to take in tomorrow's video, and probably from tomorrow onwards the state space analysis we are going to initiate. So I would hope that you are enjoying my lecture. If any kind of the feedback as well as any kind of doubt you guys are having, you can just put it in my Telegram group. Then we'll meet tomorrow with the same enthusiasm and yes, few number of problems based on the concept of the gain margin and phase margin in tomorrow's video. Thank you. Thanks a lot.